This lesson is about similar polygons. So, similar shapes. We have a little symbol, looks like a little squiggly sign. Shapes are similar if their corresponding angles have the same measure and the corresponding side lengths are proportional. Corresponding basically means that they are in the same position or they match up with each other. So if we look at our home plates here, we can look at our angle measures. We've got 135 degree angles and we've got 90 degree angles. So we can see that our angles all match up. Means these are going to be similar to each other. Also, we can look at our side lengths. So you can see the 8.5 inches or 8.5. Oops, wrong one. This 8.5 matches up with the 17 here. If we divide that out, 8.5 divided by 17, you get a half or 0.5. Same idea here. 4 1/4 is 4.25. Matches up with this other 8.5. If you divide, you get a half or 0.5. And the 6 matches up with the 12. 6 divided by 12 is a half or 0.5. So since these are similar, those sides are going to be proportional. In other words, if we take our corresponding sides and divide them, we'll always get the same fraction or decimal. So if we look at this example, we're trying to figure out if these polygons are similar. They've not given us any angles, so we are strictly going to be looking at the side lengths. They've started this out and they've given us one set that they've compared. They compared the 3 to the 2. So if you'll notice, the 3 comes from the trapezoid on the right. That's always going to be my starting spot whenever I do my fractions then. I have to be consistent and do my fractions all the same way. So 3 divided by 2 is 1.5 or 1.5. If we do a 5, the 5 matches up with the 3.75. So 5 divided by 3.75, we're going to get 1.3 repeating. And then the last one, the 7 would match up with the 5.25, and if you divide that, you'll get 1.3 repeating also. When you divide these, if these are not all the same, then this is not going to work. So you can see these are not all the same, they're not proportional, so the two polygons are not similar or aren't similar. If they were all the same, then they would be similar. Example 2 is triangle ABC similar to triangle FED. So if we look at our triangles here, you can see on both triangles we have 110 degree angles and we have 30 degree angles. It's actually not essential, we'll talk about here in a second, but you may remember in a triangle the angles add up to 180 degrees. No matter what our triangle looks like, the angles always add up to 180 degrees. So actually we've got our missing angles are both 40 degrees. Okay? Now the book mentions here is that even by two angles, if we have two angles that are congruent, then the triangles are similar. Okay? This only works for triangles. We can't do this for rectangles because rectangles, or quadrilaterals I should say, You know, I could have a rectangle. You know, obviously there's two right angles there. I could have another quadrilateral that has two right angles, but just because it has two right angles, like the other one, this quadrilateral is not going to be the same. Okay, this one maybe is a sand crawler here. Trapezoid. So it doesn't work with rectangles, but with triangles, if you have two angles that are the same, the other angle automatically is going to be the same because you've got only 180 degrees to work with. And not only that, we actually don't even have to know what the side lengths are. If you have two angles in a triangle that are the same, your third angle is going to be the same. Your triangles always will be similar, no matter what. If your angles are the same in a triangle, your triangles will be similar. Okay, so the answer is that these are similar. So they said here, triangle ABC is similar to, remember that little squiggly means similar to triangle FED. Now, when they say that, the order they have their letters in is important. ABC, FED. Okay? Look at where these letters are. Here's an A and an F are the first letters. Let's go back and look at our picture here. A and F both are 30-degree angles. B and E. B and E are both 110-degree angles. And our last letters, C and D, are both those 40-degree angles. Okay? So what happens when we make that similarity statement, we're putting those in order where if they're in the same position, they have the same angle measure. When you make that similarity statement, there's nothing necessarily magical about the way that they wrote this in the book, A, B, C, and F, E, D. There are other ways that we could write this. For example, we could say BCA, triangle BCA is similar to triangle EDF. Okay, notice the B and the E are in the same spot just like they were before. The C and the D are in the same spot just like they were before. And the A and the F are in the same spot just like they were before. Okay, so there's multiple ways that we can write that same similarity statement and still be correct. We just have to make sure when we write it that the angles that are the same are in the same positions. Okay, so let's look at the other question they have here. Which side of triangle FED corresponds to segment AC? So AC, there's two ways we can do this. One way is to look back at our picture. If you look at AC, we've got a 30-degree angle and a 40-degree angle. So if you look at the other one, you can see that's going to match up with FD. Another way we can actually do that, so there it is, FD corresponds or matches up with AC. Another way we could do that is we could look at our statement here. So AC, we've got the first and the last letters here. Take the first and last letters in your other one would be FD. So if we did our similarity statement correctly, we should be able to just look at the order of the letters and figure out which side matches up with it without even looking at our picture. Example 3, they want us to find the length of segment BC. And notice they told us triangle ABC is similar to triangle FED. So if we're trying to find the length of BC, So if we look at our similarity statement here, BC is the last two letters here, matches up with ED. And so that means those sides correspond to each other. So BC right here is X, that's what we're trying to find, matches up with ED, which is 24. So I'm going to do this a little bit differently than what the book's doing. So I'm going to say that X matches up with 24. By the way, what we're doing here, we're going to do a proportion, because if the triangles are similar, the sides are proportional to each other, we talked about. Okay, so 10 matches up with 24. The deal is, since X matches up with 24, X was from this first triangle. On my proportion, since I started with the X here, I have to start with something from that triangle on my second fraction. Since they've given me all the numbers here, I'm going to start with the lower number. I'm going to start with that 35. If you chose 55, you could do that, also would work. Okay, the 35, you can either go back and look at your similarity statement and say 35 was BA or AB, which is the first two letters. It's going to match up with FE, which is 28. Or you could look at the angles in this case. They gave me the angles. BA, it's a 110 and 30 degree angle. So 110 and 30 degree angle gives me that 28 centimeters. They don't always have to give us the angles on these problems though. So make sure we know how to do it both ways. On this problem, I'm trying to figure out what X is equal to. So I might be looking for a pattern multiplying or dividing going towards the variable. In this case, I don't see a pattern. Sometimes, not always, but sometimes we can reduce the fractions, and sometimes when we do that, it will create a pattern that we didn't see before, or that we didn't have before. So if I reduce the 35 over 28, if I reduce both of those by 7, I'm going to get 5/4. And now I actually have a pattern here going towards the variable. I have a pattern going from 4 to 24 would be multiplying by 6. So if my denominator is being multiplied by 6, my numerator also multiplied by 6 if these are equal to each other. And so that would mean X is equal to 30. So 30 centimeters would be the length of segment BC. So on the try it, it says that these are similar. They're asking what the length of segment GH is. When I do these proportions, I like to start with what I'm trying to find. So I'm going to start with that GH. You can put an X there, you can put another letter there. And if you kind of look at this, look at the angles and things, hopefully you can see that that side GH matches up with the side that's 15 millimeters long. Now, since I started over here, my numerator has to come from that same figure again. So we can choose to put either a 10 there or a 25. They've given me all the numbers, so I can actually pick either of them. So I'm going to pick the smaller number, the 10. And the 10, if you look, has both the right angles there next to it. So that's going to match up with the 8 from the other figure. Now, on this problem, I could reduce the 10/8. Even by reducing, the pattern's not going to be there. What we can do, though, talking about solving equations we've done before, if you look at the variable is being divided by 15. we talked about solving by doing the opposite operation. So the x is being divided by 15. If we multiply by 15 on both sides of the equation, multiply by 15, those 15s are going to cancel, and I'll just have an x left there. So then it's just a matter of simplifying. 10 times 15 is 15, 8 times 1 is 8. And then if we do 150 divided by 8, we'll get 18 and 6/8 or 18 and 3/4. If you did this on a calculator, divide it out, you get 18.75. Same thing. Okay, so 18 and 3/4 millimeters would be the length. When you guys do these problems, you will always either have a pattern, or if you don't have a pattern, if you start with your variable in the numerator, they will always be dividing, and you can always multiply by what they're dividing by to find your answer. So it's always going to be either a pattern or you're going to multiply. One of the two. So the key concept here just mentions polygons are similar if corresponding angles are equal, and then if we have that, also the corresponding sides will be proportional. Let's look at the do you know how. Number 4 says, is triangle ABC similar to triangle MNL? This is almost identical to the problem we looked at earlier. We can see a 25-degree angle here and a 90-degree angle. So we can say yes, these are similar because we could say there are two pairs of congruent angles. Congruent angles, congruent just means that they're the same measure as each other. The angles are equal, basically. Okay, so those would be similar, first of all. And then number 5, we're trying to find which side of triangle MNL corresponds to segment BC. So again, a couple ways you can look at that. BC, if you want to, you can look at your angle measures here. We got a 25-degree angle and a 90-degree angle here. So if you look at your other one, 25-degree and 90-degree would be NL. So it matches up with the National League here. NL. Okay. Also, we could do that by our statement on 4. We said these were similar. So if you look, notice BC would be the last two letters here. BC, last two letters. NL, last two letters. So there's a couple ways you can figure out that those are corresponding. Okay? Look at number 6 then. It says the two polygons are similar. Angle B is congruent. So that symbol there, again, that squiggly with the equal sign under it means congruent. Angle B is congruent to angle R. What is the length of UT? So they're not saying like angle B is 30 degrees and angle R is 30 degrees. It doesn't really matter. It's just the fact that these angles are equal to each other. So they're equal. We can put a little mark there, put a little arc underneath both of those. That just means they have the same measure as each other. Okay. What that does, that gives us a reference point. So if I'm trying to find the length of UT, I'm going to put an X over here. UT, I can look at where that side is in relation to the angle that I know. So this we can see is directly below that angle that we know. So directly below that angle we know here would be the 10 inches. Okay, so what we can do to find that length, I'm going to start with what I'm trying to find. So I'm going to start with my X. If you want to use a different letter, that's fine. The X matches up with or corresponds with the 10. And that's going to be equal to, starting from that same figure, 8.4, which matches up with 14 in my other figure. Now to solve this, I don't really have a great pattern here. If I don't have a pattern though, that means I can multiply. They're dividing by 10. I'm going to multiply by 10. When I multiply by 10, that moves my decimal over. So I've got 84 divided by 14, which will be 6 inches.